Okay, hi everyone. This is an absolute value graphing video. I have another one of these, a level 1 video, but this is for those of you who have learned how to do absolute value and want some more help with it. So here's how it works. We're going to just try a problem here. We're going to graph y equals 2 absolute value x minus 1. I want to graph this equation and see what it looks like visually. So I'm going to be placing it on the graph over here. And to do this, probably the easiest way we could go about it right now is just make a table. So that's what I'm going to do. I'm going to make an XY table, and I'm going to pick some X values to graph. And I know, based on what I've kind of been telling you in class and what we've been practicing, that this graph should resemble some sort of shape that looks like a V, either pointing up or it can point downwards. So I'm expecting this kind of shape. And so what I really want to figure out is where is this point? Where is this vertex on the graph? This is an important point because if I don't find the vertex, then I'm going to end up probably graphing a line by accident. So I'm going to plot a lot of points and try and figure out where that vertex is happening. So why don't we pick for our x values? Why don't we start with some random numbers like -3, -2, -1, 0, 1, 2, and we'll go from there. Hopefully we'll find a pattern within this data. Now the fact that we know the equation means I can easily, for my table, I can write y equals 2 absolute value of x minus 1. I can write that right here. And I can actually show my work in my table. I think I'm going to do that just to make this easy. So what I'm going to do is I'm going to take each number here, starting with -3, and I'm going to basically substitute it in, plug it in. So 2 absolute value x minus 1 means I'm going to do 2 absolute value -3 minus 1. Now let's do the math on that. -3 minus 1 is -4. So this is 2 absolute value -4. And absolute value of -4 is +4. So 2 times 4 is 8. All right. So here is my first table value. I got 8. So on my graph, at -3, there's a value at 8. 1, 2, 3, 4, 5, 6, 7, 8. And there's my first point. All right, let's keep going through this process. Let's do -2. So 2 absolute value, -2 minus 1. Let's do that math. Well, -2 minus 1 is -3, so I have 2 absolute value -3. And since the absolute value of -3 is +3, 2 times 3 is 6. So now at -2 on my graph and up at 6, I have a point right there. Now I'm going to do the next number, -1. So 2 absolute value, -1 minus 1, is going to equal -1 minus 1 is -2. So I have 2 absolute value -2. And absolute value of -2 is +2, so 2 times 2 is 4. So I have at -1 a point at 4. Okay, so far all my data is looking like a straight line. So I can't stop. I can't be like, oh, I figured out my graph. I'm all done with my table. I'm still trying to find this vertex point. So let's do 0. 2 absolute value 0 minus 1. 0 minus 1 is -1, so 2 absolute value of -1. -1 becomes a +1. 2 times 1 is 2. All right, so at 0, we have a point at 2. It still looks like a straight line. I'm not finding the V yet, so let's keep going. Let's do 1. 2 absolute value, I'll plug in 1. 1 minus 1. 1 minus 1 is 0, so I have 2 absolute value of 0. 2 times 0 is 0. All right, I'll go to 1 and 0. That still looks like a line, so I got to keep going in my table. I'm just going to keep on going. Let's do 2. 2, absolute value 2 minus 1. 2 minus 1 is 1, so I have 2 absolute value of 1. 2 times 1 is 2. All right, so I'm going to put 2, 2 on the table. 2, 2. Finally, I see my V. It's finally made a turn. This is what I was waiting for, is for these points to turn around. Now I'm like, okay, I bet you 3 I bet you I can figure out what 3 is. I bet you it's going to be 4, but we can double check it. Let's put 3 in there. 2, absolute value 3 minus 1. 3 minus 1. I'm going to do that math. 3 minus 1 is 2. So 3, absolute value of 2. 3 times 2 is 6. Oh, oops, I misjudge it here? Oh, wait. I just made a mistake. Sorry about that. This is a 2, not a 3. Why did I do that? It's a 2 on the outside. 2 times 2 is 4. See? Good thing I'm double checking my math here. So it should follow a pattern. I expected the answer to be 4, and I got a 6, and that threw me off. Well, there's why. Okay, so 3 is supposed to be at 4. Okay, it's totally looking like a V. Now I'm not going to worry so much about doing any more table points. I have a huge table here. I'm going to connect my points with a line going in both directions. And I'm going to extend this line with some arrows because it doesn't stop here. I'm just stopping because I'm tired of making my table. And this is y equals 2 absolute value of x minus 1. And I'm done. So let's try one more of these. In fact, for the next one, I would really like you to try it yourself. Maybe pause the video, see if you can get it right, and then unpause the video. So for this one, we're going to do kind of a harder one. Y equals negative absolute value of x plus 1. Let's try that one. So yeah, pause the video, try making your table and graphing it, and then unpause the video and see if you get it right. Okay, so I'm going to go through my steps here. I'm going to make an XY table. And again, I'm going to be searching for the V, so I'm going to be doing all the work to find the V. And I'm going to write here y equals negative absolute value of x plus 1. So I can have some room to show my work. And I'm going to pick some values, maybe the same strategy as earlier. Negative 3, negative 2, negative 1, 0, 1, 2. And I'll just do as many points as I need to. Now for negative 3, I'm going to be placing it inside of this equation. So this one's a little bit trickier. It's a minus absolute value. And then I'm going to change the x into negative 3 plus 1. So let's go through that math. Negative 3 plus 1 is negative 2. So I get a negative 2, but it's inside the absolute value, and on the outside is still this minus sign. So now what's the absolute value of negative 2? Well, it's positive 2, but there's a subtraction negative sign on the outside, so it turns back into a negative 2. So my first point is at negative 3, negative 2 on the graph. Negative 3, negative 2 right here. You can see why this one's a little trickier. So let's try negative 2. So I have a minus absolute value. X plus 1 is going to be negative 2 plus 1. Negative 2 plus 1 is negative 1 absolute value. But on the outside, I have a minus sign. So negative 1 becomes a positive 1. But then with the subtraction sign on the outside, it turns back into a negative 1. So at negative 2, I have a point at negative 1. All right, next one, let's do negative 1. So minus absolute value. X plus 1 is negative 1 plus 1. Negative 1 plus 1 is 0. So I have this minus absolute value of 0. Well, that's 0. Okay, so at negative 1, I have a point at 0. So it's just looking like a line. I'm not seeing the V yet, so let's just keep on going. Let's do 0. Negative absolute value. X plus 1 is going to be 0 plus 1. 0 plus 1 is 1, so I have the absolute value of 1 with a negative sign on the outside. So the absolute value of 1 is 1, but with the negative sign on the outside, it turns back into a negative 1. So I have a point at 0 and negative 1. So here's 0, here's negative 1. All right, I'm already seeing the V. It goes up and then it's starting to go back down. So I'm expecting the next answer to be negative 2, but let's check the math on that. Negative absolute value, x plus 1, it's 1 plus 1. 1 plus 1 is 2 in the absolute value, but there's a negative sign on the outside. So 2 absolute value is 2, but with the negative on the outside, it goes back into a negative 2. So I have a point at 1 and negative 2, and sure enough, I'm feeling very confident. You can see the V now. It's going in this direction downwards. I'll draw some arrows. And I have my graph. And I'm going to write y equals negative absolute value x plus 1. This time the vertex is right here at -1. It's on the x-axis. It's a root, it's a vertex, and it's all pointing downwards. So I'm going to circle that and label it. It's my vertex, and it's my root, or my x-intercept. So kind of an important point, a key point on this graph. Okay, I hope that helps. These ones with the negatives on the outside are probably the most difficult out of these linear absolute value problems, and we're going to continue working on them in class. Cool. Thanks, guys.